Hello, welcome to an exciting episode of Geek Out with Perry, the first episode covering the new Exchange. Over the past few years, we've seen big changes in the way people communicate and work with each other. There are a multitude of different types of devices, an explosion in the amount of information we all deal with, hardware changes, an increasing number of compliance requirements, and a shift towards cloud services. So let's talk to Perry about how we've evolved Exchange to help meet these challenges. Hi, Perry.
Hi, Ann.
So how has the architecture changed with the new Exchange?
Well, there are a fair number of changes in this release. We've gotten a lot of experience running the service now, fairly large scale. A lot of these changes are aimed at trying to simplify the system up and down the stack. Taking back at looking at sort of a classic 2010 deployment, starting at the top, we have something that most people are going to have to deploy, which is called a Layer 7 load balancer.
Okay.
It's a fairly complex and expensive piece of equipment, hard to manage, and its job is to make sure that when requests come in, they stay sticky to a particular CAS server.
Okay.
The reason you need to do that is because our CAS servers have a bunch of business logic and session state that gets built up. And if you're constantly hopping between CAS servers, the experience will get choppy, and the cost from a performance perspective on rebuilding that session state for each request gets really high. Okay, and it affects both the amount of processing that has to be done here and also the load on the back ends. So making sure this Layer 7 load balancer understands enough of our application logic and looks at individual packets to make sure that they're going to the right place, and getting that all set up properly is complex and expensive. So that was one of the key things we really wanted to address in this release, is to replace that Layer 7 load balancer with a Layer 4 load balancer.
Okay.
And that just means that we're going from session affinity to TCP affinity. And
Okay.
it only needs to worry about getting an individual request to one of the CAS servers that are in the array.
Okay.
All right. To do that, we needed to really take a look at what was the right things to put in a CAS server. And if you're only going to have requests come in for a particular request stay sticky on that CAS server and only do TCP affinity, you really can't afford to build up an awful lot of session state on those boxes. So we split the CAS server logic and just restricted ourselves to the auth, proxy, and redirect functions. You can sort of think of it as we have split this logic here, but now it is this CAS server that's going to do that session affinity work.
Okay.
For us, that session affinity work gets a little easier because we moved the components that you're all familiar with. The OA, EWS, POP, IMAP protocols, all that deep logic associated with those things, back to the mailbox server. So all of that session state, business logic,
Protocols.
and protocols, the deep protocol handling and so on, all gets moved back to the mailbox server. And now the CAS server just needs to do an Active Directory lookup to find out where the mailbox is,
Okay.
and go back to the mailbox server that you own. So if a request from you comes in, it's just this is an AD lookup and finds out which server to go to. And then when we build up a session here, we can only have a caching strategy that maintains the data for a session, but because you're always going to come back to the same server, we can have caching strategies that last longer than that, which gives us a big advantage in terms of long-term efficiency. And then any requests at this level, this interface tends to be a little chattier. Of course, not having to do a network hop gives us a small performance improvement.
Okay.
And then in this release, we actually did a rewrite of the store to be a managed store. managed store process. And that gave us a few important wins. We still got our core store engine.
Okay.
And we also introduced Fast Technology as our content index engine.
Okay.
In the rewrite of the store, we got several big wins. One is we got another 4x reduction in the I/O per user operation.
That's great.
So I'll show that by showing a 4x reduction in the number of spindles you need to support it, the number of users you'd normally have on the mailbox server. And then also the logic in the store got a lot simpler because we have, over the last 3 releases, been moving business logic out of this store management layer into our business logic layers and creating a nice, well-tiered, well-structured service. All that's maintained. We get the benefits of co-location in terms of caching and those sorts of things. But we now could remove an awful lot of the complexity of the store logic that had been there sort of as a legacy thing. So this layer is now quite a bit simpler. And that's one of the reasons we got the I/O improvements out of the system.
Okay, so with Exchange 2007 and 2010, we had a lot more server roles. So what happened to them with this new release?
Okay, so again, one of the key goals here is to make the system look simpler, have fewer roles to manage. So you could always think of, in 2010, you always had your SMTP sitting out here, maybe a SMTP front end, and then a hub. And then you might have an edge SMTP out here, right?
Yeah.
Edge transport. Okay. And the hub server would do the delivery as a remote system. You'd have to worry about making sure that all these things play nicely with your load balancers and your firewalls and so on. But the analogy between an SMTP and a hub and what was going on in terms of this business logic of something like EWS was pretty straightforward. So in this model, the SMTP front end is just part of the CAS array, and every CAS server contains that function, and then every mailbox server here is also basically acts as a hub server.
Okay.
And again, the deliveries will largely be local for the hub server, so he's only going to have to worry about making deliveries locally to the server. And then in the end, this unit creates a nice unit of upgrade.
Okay.
Right? It tended to be that as this business logic got complex, you get tight dependencies across the system. Well, on different servers, it created, it's sometimes a fairly complex upgrade dance. In this model, this is a very simple, thin server role, and it is easily backwards compatible. And the complex interactions between versions is taken care of because we can upgrade this as a unit across not just OA, EWS, and the hub, but also the role follows the same pattern. So everything is a nice, straightforward pattern that you get used to. You have a set of a small number of CAD servers that get deployed, roughly the same number of mailbox servers as you had, dramatically fewer spindles that need to be managed. So overall, I think this is a significantly simplified solution.
So what about high availability in this new system?
Okay, so it's actually a key part of making this work. Over the last couple of releases, we've been working a lot on our high availability story. And one of the interesting things we discovered was that we could get really good at doing failovers and doing that very quickly. If we ran into an issue, we could get a failover done in 30 seconds or less. In principle, historically, one of the reasons for driving logic to this middle tier layer is this idea that because it's sort of stateless, you could manage it easier by taking these servers out of rotation fairly easily, right? If you manage to drop. But it did mean that you had this interesting work to do to not only know that there was something wrong in the system, but also to make sure that the layer 7 load balancer was aware and could take the thing out of rotation. We found that working across multiple vendors and also doing the work to understand that not just from a availability perspective, but a quality of service perspective, that something, that there was an issue at this layer was getting hard to do.
Okay.
And the model was becoming much more like the richness of what we're doing from our high availability solution in terms of knowing it's time to do a failover or a restart at this layer. So by moving this down, it really drove us towards putting into the product something that we've been using in the service quite a bit, which is called sort of managed availability, which is just a built-in monitoring system that is very good at looking at all the different components and being able to report on their health. From an alert perspective, from a artificial transaction perspective, so that you can actually measure the quality of service that's going on from a performance perspective or a failure perspective, and then take the appropriate actions automatically, right? So there's monitors that are checking the behavior of the system, and then there's a set of actions that are going to happen based on those things, okay? And some of those are going to be restarting individual processes, and some of them are going to be failing over individual databases to other servers, which will then make sure that the business logic for a particular mailbox also moves with it. And some of it is going to be failing over a whole server if we suspect there's something deep about the OS or the hardware on this box that's driving poor performance or failures at this layer, or this layer.
Okay.
Having built that and used it in our service, we're getting very good at tuning down the noise and getting very good at being able to measure and react to a large list of failure modes. And then up here, the ability to detect if something's going wrong is very simple. So being able to take these guys in and out is very rare, or the need to is very rare, and the ability to detect it is pretty simple. So the managed availability stuff is really building on the real-time experience we're getting running this in the service, and getting that shipped as part of the product is pretty exciting.
So you talked about synthetic transactions and probes. So what does this actually mean in high availability?
Okay, so if you're just detecting that a database is offline, it's pretty straightforward. But if you've got a large set of protocols, and somebody's phone isn't working, but everything else is working, you still want to detect that. Or they're not just the phone's not working, but things are slow, right? The requests coming through are slow. It's difficult to do that just from taking a look at alerts and errors that are being thrown. You really want to drive transactions that go through the entire stack, and make sure that the metrics that you're seeing on those transactions reflect what users care about, right? So not just do I get a response back, but does the response come back quickly enough, and does it have the right content in it? Some of this we measure directly through performance counters that we set thresholds, so that's part of the system. But the goal here is, through managed availability, is to detect the full quality of the service, and then take the appropriate reactions automatically, so that very, very rarely do you have to take the long time out for a human being to come in and figure out what's going on and take the correct response.
Okay, so it's not just about uptime, it's now about end user experience and true availability.
Exactly.
So that HA story is really great when we're talking about one site. What have we done in the new Exchange if I am a user and I want high availability, but I have multiple sites in my organization?
Okay, so one of the big advantages of moving to this model was it really enabled us to simplify the management of a single namespace for your deployment across your whole company, across the entire world. For a large company that might have people that are working in multiple continents, you might have a world in which you have mailbox servers in Asia, spread across, say, 2 different DCs for high availability. These guys are a DAG. Okay, and in here, again, you've got mailbox servers spread across multiple sites here. And in each of these sites, of course, you're going to have your own CAS array in both sites.
Mm-hmm.
Okay, so VIP1, VIP2, VIP3, VIP4. So user, who's normally working somewhere in North America, wants to connect. You go through GeoDNS. Says, okay, looks like you're in North America. Mm-hmm. I'm going to give you a random round robin between these two VIPs that have been published, and I'm going to point you to VIP2.
Okay.
And it's going to come back to the CAS server, and this CAS server is going to go back to your mailbox server in the other site.
Okay.
Remember, this is very stateless. It's kind of a one-to-one proxy, so it doesn't really matter where this is in terms of how close it is to the mailbox server. But because this auth process can terminate a bunch of round trips, mm-hmm. it's actually good to have this as close as possible to this person. So if she flies to Asia mm-hmm. and does the request, she's actually going to get pointed to one of these two VIPs, even though her mailbox server is, again, back here in North America.
Okay.
So it's going to come through this CAS array. The initial loft is going to be very quick because it's close to her, and those round trips get short-circuited, and then she gets passed back to her mailbox mm-hmm. server back in North America.
Okay.
So it means that you're take advantage of your CAS arrays across the entire world so that when people are moving around, they get a great experience. And as well, if you were to lose one of your DCs, mm-hmm. remember, this VIP has gone away, but this is just part of the round robin. So she'll end up just going back to here. And as soon as the database failover should happen, remember, we can do that very quickly, there will be this seamless transition to the failed over DCs. This will happen worldwide. And then one final note, the single namespace can be maintained across version upgrades. So the upgrade story is pretty straightforward this time around.
Oh, great. So we drastically simplified the whole namespace story.
Yes.
Thank you so much, Perry. Do you have an important question for Perry on the new Exchange? Well, you have an opportunity to ask him. We're doing Geek Out with Perry live at MEC, so if you have a question, tweet us using the Ask Perry and MEC is Back hashtags, or send an email with your question. It might get answered by Perry at MEC. Thanks for watching.